Mushroom Wonderland.
Hey, what's up? This is Aaron Hilliard, Mushroom Wonderland. I got Sidnee here with me, Sidnee Obersingleton. We're gonna go on a blacklight foray looking for mushrooms that are fluorescent, right?
Yeah.
Are there any bioluminescent mushrooms around here? Like
absolutely. Usually you won't see them until you have a lot of moisture in the area. A lot of the bioluminescent species will only have glowing mycelium.
Oh.
So it's when it gets real wet and it gets it'll grow towards the surface and kind of get exposed. You'll be able to see it. And a lot of them are like tiny little mycena. There's all these little things. You really need a moonless, like perfectly pitch black night for it, though. It's kind of its own type of hunt.
Awesome.
Yeah.
Well, we're going to find out what we can see. We all got UV flashlights. I'll put the link in the description if you want to get. I got like a 400 nanometer ultraviolet flashlight. So, and it was pretty cheap on Amazon. I think it's like $25. So, yeah, thanks for joining Mushroom Wonderland. Hit subscribe, hit that like button, and let's go in the woods and see if we can find anything that that glows or fluoresces. So, yeah, let's go do it.
Absolutely. Big old convoy. I think it's a C8. And then I have this little one, which is a 395 of like moderate quality. It works, but it's great to have both wavelengths available. So like this is a 395, like the same wavelength as yours, and then this is at 365, like
oh wow,
dimmer and more blue, kind of like side by side. You can see the difference. So if you look at it under 365, it really just kind of looks like all red against more or less a dim bluish white background.
Yeah.
And then if you hit it with this, you'll see you get what looks to our eyes a lot brighter with a lot more purple washout. Cameras tend to have a better time picking this up, but you also just get less of the purple. You get a truer color with 365, and also because it's a shorter wavelength, it's actually more energetic and it can cause more things to fluoresce. So for some things, only 365 will make it glow. For others, only 395 will make it glow. That's why I like to have both on hand.
Wow. So what do we find here?
Beautiful. These are Hypholoma fasciculare, the sulfur tuft. Kind of bright yellow in normal light.
Oh my
sulfur
god.
Colored, but then under UV, they're just insanely fluorescent, especially the gills. Absolutely beautiful. One of my favorites to find on a night foray. Just they're so impressive.
Beautiful. I was hoping some of these would be out here.
These are really good looking too.
I got my fancy camera. I want to get a picture for sure.
Yeah. Thankfully, it's right by the start.
Yeah.
For photography, both of you have like kind of wide beam lights. Those might actually help for these.
So yeah, this is the Hypholoma fasciculare, toxic, also known as the sulfur tuft. Wow.
Probably one of the brightest fluorescent mushrooms you'll find.
I keep seeing these little stringy things, but it's probably fabric.
Plastic.
Yeah.
That's mycelium coming out of the end of a log.
Probably a fomitopsis.
Yeah, more than likely. It looks like a brown rot.
So these are the shells of a millipede.
Yeah, that's so.
And you say that a live millipede is going to glow like that?
Oh yeah, they're super bright. Probably one of the brightest like arthropods you'll find.
Yep, look at this log. More of the Hypholoma fasciculare. Wow, they're like purple in the center. And that's kind of the color of the spores even, which is interesting.
Nice little cluster.
Yeah, shine on those. Oh my gosh, look at that, people. Can you see that?
Oh.
Let me flip one over and the gills are just...
Yeah, the gills are just phenomenal on these. It's almost like too bright in person.
Yeah, I can't, the camera really can't pick it up. It's just...
Flooded.
So bright.
Wow. Yeah, all along the bottom of this log. Super cool.
So now I'm seeing that this ultra bright one might be like too much. What do you see here? Oyster mushrooms, yeah.
These are oysters. Let me get a little closer. Oh yeah,
Yeah.
definitely past their prime.
Oh wow, there's some way up there. Does that look like Foliota?
That one actually might be Foliota.
Brown spores, it's got a stem. Look at that.
Yeah. Yeah, we got two saprobes on one tree. This looks like it might have been a maple at one point.
Yeah.
This one is probably what they ate first, judging by the decay. Man, it's too bad we didn't catch these like a week ago.
Right?
This is another one of those plant decay fungi. It'll produce this orange pigment in leaves as it eats them.
Oh wow, cool.
And that orange is just not visible at all in normal light. And you can see it corresponds with this more rotted portion of the leaf. Again, I also have no idea what species does that, but each species of plant seems to have different fungi that fluoresce that'll grow on their leaves.
It was pretty bright up there.
Yeah. We got another one here.
These are just tree conchs that are...
I can step like 5 feet away too, if that helps.
Yeah, back up a little bit. Let's see.
The dim ones are a
it's,
lot better for photography.
that's better. So this is a lichen grown on a little twig that's about as big around as a dime. Really bright yellow.
Really cool because they're not yellow at all in normal light. Just a pale white green. You can see little tinier colonies on a lot of the twigs too. Yeah, that one's just white under normal light. In fact, this one. Coming out of the wood. Looks like we got some.
Picepes?
Yeah. Picepes or Royoporus or Polyporus or whichever name is used for these now. The black-footed polypore.
Yeah.
Super common on like small maple branches. It looks like we got a little bit of a color thing going on, a smaller one especially.
Yeah, that one definitely caught my eye.
Yeah, nice bright underside. Definitely looks cool. Yeah, some mushrooms you'll walk right past in normal light, but UV will highlight them immediately.
Yeah, I would have never seen those in regular light, but
yeah. There's a few acids that this and Avernia share. They both will get this kind of like orangey color under 365. It is a good example though of where wavelength makes a big difference in the final color you get out of it. So like with purple, there's kind of competing red tones that come in with the purple, whereas with this you really get more of a true color.
Oh yeah. Is that sap on it, those white spots?
I actually don't think so. Because you see here on the underside,
yeah.
I think it's actually dead portions that have had their metabolites, so the fluorescent portions washed out over time.
Oh, cool.
Or sometimes on lichens it'll actually be like bacteria that grow and change the fluorescence.
Yeah. Oh, something just bit me hard.
Oh, really?
Dude. Whoa, shit, are we on a bee's nest?
Yeah, let's get away.
Oh, yep, I'm getting stung. Oh. Yeah, we were stepping on a bee's nest. One got me on the back of my elbow.
Ouch.
And
are you allergic?
Top of my hand, I sure hope not. No, I'm good. I'm just a wussy. That sucked.
Probably far away enough now.
Yeah.
They're sleepy.
Ow, those little suckers. I was like, what is going on my hand?
Yeah, you reacted quick enough.
Whew. So.
I don't think I have any on me.
Dude. All right, yeah, stepping on bees nests in the dark.
I went on the other side of the trail.
Yeah.
Well, there's a first for everything. Is there bees on my pack? And
I've gotten real lucky. I've never stepped on one.
Dude, that guy got me. This dude on my elbow too. All right. It's been a while since I've been stung.
Yeah, it's been years for me.
So, bees do sting at night, just so you know. If you ever wondered, they were quiet. They were stealthy bees. Ouch.
Very first alert was a sting.
Yeah. I'm like, ow, that hurts on my hand. But the guy on my elbow, he was angry. Oh, yeah.
Hyper aware. I think there's like bees all over me.
I am too. I'm scared to step off the trail now.
I've seen 2 eggshells. I wonder what birds these are coming from.
Oh, really? Eggshell. Probably a mountain biker who's eating hard-boiled eggs on his trail. I don't know.
Yeah, it glows green. That's really cool.
Whoa, hello. You hear that?
Yeah.
That's called the boogeyman. No, I'm just kidding. It's a Sasquatch.
Was that an owl?
No, if it was a Sasquatch, you'd smell it.
I think it was an owl. Bizarre.
That's real.
It's a big bird.
Here, if I get my light out, I wonder if we can start eyeing.
Wow.
It sounds like it might be coming from. It's like right there.
This is like one of those, it's near Halloween, and this is like the dumb white people in the movie that are like, what's that scary sound? Let's go toward it.
Closer.
Yeah.
It's fresher than the other.
Oh, dang. Look at that. Sidnee spots there's no bee's nest right here, is there?
I probably know by now. Let's give it a flip. We got interesting kind of orangey yellow on the gill margins right there. I don't know how well that shows up. And we got all these like beetles. Oh
yeah.
my gosh, a lot of beetles in those gills.
This is your average Pleurotus ostriatus, the oyster mushroom. Yeah, these are just like buttons at best, and then...
So it looks like this is something fluorescent growing on top of a really old fallen polypore.
Oh, yeah.
Maybe something like Hypocrea, the sexual form of trichoderma, but it looks really, really old. But it'll form these sort of cushion-shaped stroma. And similar to the lobster mushrooms, when they're fresh, they'll be dotted with the openings of perithecia. That's odd. You know, it doesn't really quite look right for trichoderma. And it's possible it's not an organism, that it's just a process in decomposition. But this one's a little more organized too. It's only on what I believe is the spore-bearing surface, the pores.
Mm-hmm.
And it's really only on the surface. You can see like where it breaks, it's just totally non-fluorescent inside. It's really only the very outer surface. It's definitely interesting. Very decayed though, whatever is going on there. Tons of foam at top. A little beat up, but interestingly, with these, there's 2 pigments. Unsure of the identity of the orange one, but towards the base, you'll see it gets kind of redder and redder, kind of towards orange, whereas out here at the edge, it's sort of this yellow-green. And what's really interesting is you see everywhere that it's been bruised or damaged, it's like pretty much black under UV. That happens really quick when you scratch it, as the hispidin gets oxidized into this melanin-like polyphenol. It'll flash orange right before it starts darkening. But it's always fun to see as it shifts towards brown. The orange flash is like pretty much like brief. You'd almost need like slow motion to catch it. It'll start darkening up, lose its fluorescent property, and go towards that black as the rest of it.
Wow.
The fresher ones, it's even quicker.
Beautiful.
Yeah, it's fun.
It's like false turkey tail. Yeah, it's
Yeah,
super duper common in
false
here.
turkey tail.
All moldy.
You'll usually see that on conifers instead of hardwood.
So we're going to try to spot a mycorrhizal connection.
So really what I'm doing is basically probing through until I catch on like a mid-sized root, and then you follow that to the end where it starts to branch out. I don't know if I pulled up a root or a stick. Yeah, here we go. So a root like this, you can pull it out, and then you'll usually see like towards the end you'll get these clumps of soil surrounding the root tips. And you can actually see, it looks like some mycelium holding this clump together. And it really helps if you can dip them into some water. But if we gently...
So they're
check this
way
out. Yep,
smaller
here's one.
than...
So that, I don't know how well you can see, that blackened root, you can actually see the mycelium coming off of it.
Oh, I see it.
Yeah, here too, these real hairy roots, those are mycorrhizae. So those hairs coming off are not root hairs, they're mycelium. And a lot of mycorrhizae, when they form, will form like a melanized cortex or a mantle around the root. So it'll actually be a different color. These two down here that are a slightly different color, they don't have the same hyphae coming off, could very well be a different species of fungi. Oftentimes on just a single branch system like this, you could have countless species. Each root tip could potentially be colonized by a different one.
Wow.
And all these little clumps that are held on, those are held on by mycelium projecting from the mycorrhizae. So like just this one root, all this carbon and all this debris is available to the tree through the fungi that are attached to it. And there's actually this whole sect of, whoa, we got some yellow mycelium there.
Oh, yeah.
That's interesting. There's this whole section of microscopy and mycology that's devoted purely to root tip morphology. Things like the black color and the shape and size of the hyphae coming off those will actually sometimes lead you to a species level ID where you can just look at a root tip and be able to tell what species it is.
No way. Wow.
Jasmine Richardson does that. She works in truffle farming, and root tip ID is something they have to spend a lot of time on. That yellow mycelium is really interesting though. I do want to check if it fluoresces. See, I would try to dissect this here, but without immersing it in water, chances are it'll just break apart. Maybe if I can just gently, because it's possible there's golden mycorrhizae under this, attached to all this.
What would that mean?
That would just mean that whatever fungus is colonizing this root has brilliant yellow mycelium.
That is so cool. So that's just a tiny little root and all this mycelium.
Wow, we're seeing more and more of that yellow.
Yeah.
Let's see. Is that one? We might have to immerse it in a container. I don't think I can get much further than this without tearing it totally apart, but like this clubby structure right there, I can't tell if that's actually a rhizomorph, so a mycelial cord, or if it might be a yellow-coated mycorrhizal root tip. Usually these dissections are done under stereo microscopy, and it's amazing. Like a root like this, as you go through it, you'll really be able to see that like it just looks like a lump of roots, but like looking closer, we have these root tips here that are black and covered with black hairs. Over here on this end, we have one covered in white mycelium, a lot less amazing looking, but those are tips as well. Over here, we have one that has clubbed tips, like swollen tips with black hyphae coming off of it. There's one here that I can't even get to because it's holding so much debris on. Really, like, just one little root like this will hold countless species.
They're eating the leaf stuff here, and then the tree's
Yeah.
getting some of that nitrogen.
Exactly. They'll break down various minerals and nutrients in the litter. They'll get carbon from the tree and exchange all sorts of nutrients that one or the other will require. But literally, like the first place I dug down, you can find all of that on a root. And these mycorrhizae are typically right at the surface where there's oxygen for the fungi to grow. And so you have to keep in mind that like just this one little root here, literally the entire forest floor is coated in these. Like every step you take, you're probably stepping on 50 different species of mycorrhizal fungi.
Wow.
It's hyper diverse, and the competition for those little root tips is insane. They're always fighting for space, which is part of why, you know, you're really just hoping for luck when you do something like throw chanterelle stem butts in your yard, because it's not like you can just have the right trees. You have to have the right trees, and then they have to fight off every wild fungus in your yard to potentially colonize those root tips.
So do like a chanterelle, for example, do they connect with plants as well, or is it mainly just the conifers here?
Just their conifer host. So if you want to get a better look at what the mycorrhizae of one known species looks like, because when you dig up a root like this, I have no idea what any of those species are. Root tips are crazy diverse. Many of those don't even form mushrooms.
Right.
I recommend, like, if you find a chanterelle, you can lift it up gently, and you'll usually, if you take the scoop of soil under it and kind of like suss it apart, you'll be able to find the nearest root. And if you follow the mycelium from the base of the chanterelle over to that root, you'll usually find the root tips of that species right underneath. The boletes, which have fluorescent mycelium, like fluorescent rhizomorphs, I was able to follow those back to the root tips, and they have orange fluorescent root tips as well as orange fluorescent like rhizomorphs. It's really, really beautiful.
So, but you see this tangled network of roots. How do you? So I have a patch of Boletus edulis. It seems to grow with these white pine trees, which are sort of rare. How do I know for sure that it's the white pines that they're growing with? Because if I could identify that, I can look for those pines better. But
really, it is difficult. Like, if you have multiple tree species
that's what it is. Yeah.
What you might have to do, you might try following the root back, but that'd probably involve digging an enormous trench.
Right.
You could probably reach out to an expert in root tip morphology, because something like a chanterelle will have a different root tip morphology for different species. There's a database. I'm not able to recall the name. I can get you a link, but it's actually a database of photos of different mycorrhizal root tip morphologies, their hosts, where they were found, and it's pretty much the only place you can get this information other than write-ups. It's the only thing like it where you'll get root tip morphologies. So Boletus edulis is one of those iconic species where if you go to that database and you search through photos, you may be able to find tree host specific species ID.
Cool.
But usually if you're finding root tips right under a mycorrhizal species, it's not a crazy bet that they're what you're looking for. Oh, that's a nice loop.
Where'd that yellow go?
There is one. Here, if you hold your phone up to it.
Ooh, yeah.
There we go. So these are looking more like yellow rhizomorphs to me than yellow mycorrhizal root tips, but they're definitely associated with the root.
And rhizomorph being plants?
Rhizomorph is actually just, it's a word for a mycelial cord. So it's a cord of many, many hyphae joined together.
Okay, so rhizomorph is a fungal term.
Yep.
Yeah.
I don't know how well you'll be able to spot that. I'm going to try moving it to...
Ooh, look at that.
Yeah, there you go. Really melanized. And you'll be able to see how they're kind of clubbed up and with all these little hairs.
I went too deep down the rabbit hole. Wait, there we go. Hold it still. Let's see. Go deep. Go deeper.
Oh, let me try to move it into focus. Almost. I don't know if your phone is trying to autofocus too.
No. Yeah, there's stuff there, people. You see that?
These are every step you take. There's mycelial networks like this. Yeah, this is the other Hypomyces that does not eat only one species. You'll see it on, looks like this might be Trametes. I found it on Trametes before. I've actually found it on Pleurotus. And it produces the exact same pigment, skyrin, as lobster mushrooms. If you can see that, there's actually the same sort of pimply perithecia. It really does look like the surface of a lobster mushroom, just on the bottom of a polypore. This is like, right here we got a mycelial fan that's glowing nice neon green. And all these little cords going through.
Wow.
Little nodes of it right here. It's probably, if we're able to like lift any of this, I bet it goes all under.
Let me shut my light off.
Yeah, these cords just go all underneath. Super, super neat. Got a cool geophyllomorph centipede here. Some of these bioluminesce. I've never found one. And then it's probably, yeah, it looks like it's kind of going through the soil here too. Lots of fluorescent things in the soil. Like really,
So
if you
this
start
is-
picking things apart.
This is mycelium, yeah?
Mm-hmm. Yep, these are little, if you look close, like here, you'll be able to see how it fans out and gets kind of furry.
Oh, yeah.
Then like over here is probably the most well-developed, like, classical fans. Where was it? Yeah, all through here, really. And we got something orange fluorescent here. I'm not quite sure what's going on with that.
Wow.
Oh yeah, there's a geophyllomorph centipede. Long boy.
It's awful bright, yeah. It looks like just like blue spray paint.
I know. And then in normal light, yep.
Nothing.
White green.
Oh, okay.
Nothing crazy.
Let's put in the comments if you like videos like this. If you find this interesting. Well, of course, with Sidnee here, it makes it interesting, like looking at mycorrhizal connections to root tips and stuff. Right on. So that was super cool, Sidnee. Thank you for the walk in the woods, despite the little bee's nest.
Yeah, it was just a little mishap. You
Yeah.
know. Things happen. I've never run into that hazard doing one of these night forays before, so added a little spice.
Yeah, it
Just
makes
a
it
bit.
memorable. So, and the mycorrhiza was super cool to look at.
Absolutely. I feel like not enough people know that they're right there.
Yeah.
Really, especially like a loop, you can get a closer look. But if you have a scope and you can bring them home and really get them apart under some water, the detail on them is amazing.
Totally. So you just opened up a whole new world of mushroom nerdiness for me. I'm going to be down on my hands and knees digging around in the leaf stuff. Yeah. So
Different types right next to one another, everywhere you look.
awesome. So thanks for joining another episode of Mushroom Wonderland. We'll see you on the next one. Much love, everyone.